1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Test out. Testing. Testing. Testing 1, 2. Testing 1, 2, 3. Testing 1, 2, 3, 4, 5. Testing 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Test out. Hey, Chuck, are we ready to get this one up there? All right, gentlemen, check your comm circuits. Make sure everything's working. Remember, we've got 12 hours of hard work ahead of us.
All right, let's make it snappy out there. Walter, are you ready? Walter? Is Walter ready out there?
Yeah, anytime.
Okay, everybody, 10 seconds. Okay, we're coming out the commercial in 5 seconds. And take 1, cue.
Hi, good evening. Well, I probably shouldn't say good evening because you'd know my heart isn't in it, because it really isn't a good evening for weathermen or for people out there like you. And the worst part about it is that I really can't paint a rosy picture for tonight or for tomorrow. Right now, let's take a look at our regional weather map and see what the satellite picture is showing us. Well, actually, here's the culprit right here. You can see it. It's a high-pressure area out in the Pacific, and it's pushing the cold front right down on top of us. So the strong, gusty winds are going to be with us until at least noon tomorrow, and that's about the happiest note that I have for you. While we're talking about happy notes, I certainly hope that the people at NASA get their satellite launched, and things will be quiet out around Vandenberg Air Force Base, and they get that taken care of before the high winds and the high cloud cover does move in. Now, let's take a look at the rest of our national weather map, and I'm going to come up with some of those real fearless predictions.
Environmental Support Center, forecaster Lieutenant Bowers.
This is the Mission Director Center down at NASA.
What's the latest information you have on the high-altitude winds?
Just a second, I'll check, sir. There's been no significant change since the last report. Maximum wind is still 50 knots at 35,000 feet, and I expect no change in those winds until after the launch window.
Okay, good. Any change in the storm front?
No, sir. The front is dissipating. There should be no weather problems for the launch.
That's great. Gives us one less thing to worry about. Thanks. You've been a great help.
Well, some of these predictions are indeed fearless because Northern California is going to remain pretty much the same for, the next couple of days. But locally, we do have some changes for you. Going to be a little bit cooler from San Luis Obispo southward into our area. We'll have some highs along the coast from the 60s, and the lows should be somewhere in the 40s. It's going to be clear, but it's also going to be windy this evening. And that means that the folks right here in Santa Maria and also in the Lompoc area and even down as far as Santa Barbara will really have a fair chance to see that NASA launch this evening. I think it's going to be a real spectacular sight, so try and get out and watch it, okay? Now, anyway, just a little bit moving down towards Los Angeles, further south, the temperatures are
T-minus 90 seconds. T-minus 90 seconds and counting.
In the early 1960s, NASA began looking for a suitable location to establish an unmanned operations center for launching scientific satellites and space probes into polar orbits. They found the Air Force's Missile Test Center at Vandenberg Air Force Base to be the site they were looking for. For one thing, it was the only location in North America where a satellite could be launched into polar orbit without overflight of populated areas. So the NASA Western Test Range Center was established as a counterpart to the NASA group at Cape Kennedy. Since then, we've launched a whole multitude of satellites and probes, many of them cooperative launches with foreign countries. We're basically a service organization. This means that a customer brings us his satellite and we launch it. We use either the Goddard Space Flight Center's Delta vehicle, which is built and prepared for launch by McDonnell Douglas Astronautics, or the Langley Research Center's Scout vehicle, which is built and launched by Ling Temco Vought. Presently, our launches are all Earth-orbiting satellites, weather satellites, investigative satellites, and such. We offer all the facilities necessary for a customer to give his satellite a final checkout, to assemble it to the missile, and of course to finally launch it. In addition to the usual technical support, we provide machine and carpentry shops, transportation, graphics, technical writers, draftsmen, and communications. All of this naturally requires a fantastic amount of cooperation and coordination among everyone concerned. But we've been in the launching business for some time now, and we've grown accustomed to the multitude of meetings, conferences, and just plain hard work that goes into the launching of every satellite. We are constantly working against a deadline, the launch date, and we have to make this final step of preparation as smooth as possible for our customers. A lot of our work has been just keeping up with the ever-changing hardware. As the satellites have changed, we have had to alter and reconfigure our boosters to get larger and heavier payloads into space. In the past 10 years, NASA's Western Test Range Group has launched more than 30 spacecraft, about 4 a year, so we stay busy. This launch, the Canadian Alouette, it represented our first major launch, NASA's first Thor-Agena launch, and it was also our first foreign cooperative launch. The Alouette satellite, a joint program of the American and Canadian governments, was launched on September 29, 1962, to study the ionosphere. It was just the start of a continuing program with our Canadian neighbors. And this launch, the Echo A-12. This is the largest satellite ever lofted into space. Well, not a satellite really, but a large balloon used to reflect communications back to Earth. It was launched June 25, 1964, on top of another Thor-Agena missile. By 1964, the Western Test Range was really a hive of activity. 2 months after Echo, we launched our first weather satellite, Nimbus A. The Nimbus was actually an experimental weather satellite, the forerunner of many others. Launched on August 28, 1964, it achieved a polar orbit where it could look down on Earth, sending us pictures of the cloud formations below. A year later, we launched our first operational weather satellite, Thor-Delta A. Unlike Nimbus, Thor-Delta A was not an experimental spacecraft, but an operational weather satellite. Launched October 22, 1965, it was lofted by the reliable Delta rocket, the first of many to be launched from the Western Test Range. Meanwhile, our Scout program got into full swing. Over a 3-year period, the trusty little launch vehicle, managed by the Langley Research Center, orbited over 8 satellites. Among them, the FR-1A, launched May 15, 1966, a French-American cooperative launch and the first successful French spacecraft. The FR-1A, like the other foreign satellites we have launched, was a scientific spacecraft designed to investigate the Earth and its surrounding space. And the list could go on, of course. The first 10 years have been very busy, very fruitful years here at the Western Test Range. But there's a lot of work yet to be done.
The spacecraft laboratory is really where all our work begins. This building is just the first stop for the satellite on its way to the launch pad. We didn't used to have all this space at the Western Test Range, but as the satellites became more complex, we had to expand our facilities here. We now have a data processing center, 4 clean rooms, and 3 bay or work areas all within this building. Here in the high bay assembly area is one of our clean rooms used for special projects. A clean room, incidentally, is just exactly what the name implies. When you've launched an expensive piece of electronic equipment, you don't want a speck of dust or dirt inside that satellite to ruin the whole project. So a clean room provides a dust-free atmosphere in which to work. Of course, not all of our customers require a clean room, but they do need a place to work, a spacecraft laboratory. This is laboratory number 2. It's quiet in here right now, but you should see this place when the technicians are in here checking out a satellite. There's so much to be done in the few weeks that the spacecraft is in this building. Circuits and systems are checked and rechecked. The satellite is put through its paces as if it were actually in space. Nothing is overlooked to assure that everything works and every part fits. A lot of time and effort goes into a launch. The technicians have to make sure that the payload will work once we get it up there for them. And that's a lot of work, too. But then that's what we're here for.
I suppose you could consider telemetry the speaking voice of a missile. Telemetry is really the missile's way of telling us on the ground what's happening during the launch. Telemetry room, Hill speaking. Yeah, we're ready to start. Okay, we'll be ready. Telemetry tells us if certain events are happening or not, what the guidance system is doing, if all the engines are burning properly, and 1,000 other bits of information.
Hi, Joe. Found the problem yet?
Yes, it's in the digital synchronizer.
How long will it take to get it fixed?
About 20 minutes.
Fine.
This room, the spacecraft lab telemetry station, is where all that information is received and recorded. The recording is done on a continuous roll of paper, or strip out, as it is received from the missile. Recording all the telemetry from a launch may look like a big job, but actually we do a great deal of work while the satellite is still in the building. During the pre-launch checkouts in the low bay, we monitor and record the satellite as it transmits telemetry, as if it were actually in space. This allows the engineers to compare telemetry strip-outs from test to test to see if everything is working. These long recorded sheets will show us what we'll see on launch day. During an actual launch, information pours into this room from antennas on the roof, from the 450-foot tower, and from the large dish antenna on the hill. Of course, as missiles and spacecraft systems have become more complex, we've had to make room for additional equipment. This computer, for example, is one of our newer pieces. Its chief function is to analyze and report quickly the status information transmitted from the launch vehicle. It is capable of presenting readouts of launch events in real time, enabling rapid analysis of the launch. New Mexico State University helps us run the telemetry station and keep current with the latest developments in electronics. They also provide us with young undergraduate students who are learning the trade of listening to missiles talk. Someday, they'll be the ones who gather telemetry from the first probes to the outer edges of our solar system.
Hello, Jim. How did the test go today?
Oh, it was perfect. I think we're nearly finished.
Now, you know that we're due to make the satellite to the fourth stage on Tuesday?
Right. The checkouts went so well today that we can easily meet the schedule.
Now, you'll be finished with the pre-launch checkouts on Monday, then?
Yeah, we'll be finished and ready to go.
Good. Look, we'll have a nice weekend, huh? And try to relax a little bit.
Yeah, thanks. Have a nice weekend yourself.
I, for one, certainly enjoy coming to Southern California. Several of us Canadians have been here before to launch a satellite. When our schedule permits, of course, we take full advantage of all there is to see here in this area of the United States. We had a terrible winter in Ottawa this year. The snow got 12 feet deep and around my house. It took me an hour and a half to dig my way out. And it's certainly nice to see and feel some sunshine for a change.
Santa Barbara is south of the western test range, about an hour's drive. It's quite an attractive, picturesque town. The county courthouse, for example, is a wonderful Spanish structure, beautifully set in a lush green park.
Down at the waterfront in Santa Barbara, it has its own version of a fisherman's wharf. It's complete with live crabs and rustic backgrounds, and the folks back home really would get a kick out of it.
And of course, there's the historic old mission of Santa Barbara. It was originally built in 1786, and it's a really fine example of the Spanish influence that you can find in all of Southern California.
The view from San Marcos Pass overlooks Santa Barbara and the Pacific Ocean, and it's quite beautiful.
Back towards the western test range is the town of Lompoc, which has the singular distinction of being the flower center of the U.S.
In the late spring, the fields around Lompoc are an absolute riot of color, and the flowers bloom. But now we've reached the exciting part of our stay here. After all these months, all the crews are working and together, and we're finally ready to mate the satellite and the rocket. It's the final part of the whole program, the launch.
After several weeks of checkouts, tests, programs, retests, long hours and hard work, the satellite is proclaimed ready. The mating or joining of the payload to the booster is a major accomplishment of engineering programming and management, for both the missile and the payload must be ready for mating on the same date. In order to meet that date, the launch pad personnel have also been working for several weeks. The main booster has been fitted with 3 strap-on solid fuel boosters. The working gantry has been pulled around the missile, and it has undergone the same intensive sort of checkouts and tests as the satellite it will launch. Now it too is ready and waiting.
This is the scene in the Blockhouse a few days from now, when everything, spacecraft, launch vehicle, and men, is at last assembled and ready to go. These men are responsible for the actual launch and have seen many satellites lofted from the western test range. They have experienced time and again the tensions of pre-launch, the fueling of the missile, the gantry rollback, the final checks, the countdown. Right after launch, this room will be quiet again. All the Blockhouse activity will center across the hallway in the telemetry station. This station provides data to the engineers on the progress and performance of the vehicle they have just prepared and launched. At launch, there will be a man at each of these recorders monitoring that thin thread of communication between us and the missile with its satellite fast on their way downrange. And for the rest of its usable life, telemetry will be the only contact we on Earth can have with one of our electronic marvels. Mating is the final major step. From here on, things will happen with ever-increasing rapidness as the launch date approaches.
T-minus 90 seconds. T-minus 90 seconds and counting.
Lock system go.
Electrical system, go.
Vehicle hydraulics go.
Vehicle hydraulics are go.
First stage telemetry, go.
Second stage electronics, go. Second stage electronics, go. Second stage propulsion, go.
Second stage go.
Spacecraft, are you go?
Spacecraft go.
Roger.
Mechanical systems go. Fuel system go.
RCO reports clear to launch.
T-minus 60 seconds and counting. Umbilical disconnect enabled. Command destruct circuit is open. Main tanks pressurized.
We're ready to launch.
T-minus 30 seconds. High-speed recorders on. TM receiving is go. All systems report. Launch is go. T-minus 12 seconds.
Reset and restart the primary clock.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Engine start. Liftoff.
Initial guidance is very good. Separation of strap-ons at T plus 71 seconds. Spacecraft systems are go.
TM, do you confirm staging yet?
Right. Staging occurred on time. Second stage is ignited
And chamber pressure is good. Actual burn time on first stage was 152.7 seconds. Second stage
Arming came at T plus 132.3 seconds. We are standing by on second stage
cutoff, anticipated at M plus 381.8 seconds. Loss of signal on
first stage telemetry was T plus 669 seconds. Anticipate loss of signal on
second stage telemetry at T plus 1042
seconds.
What's your dropout rate?
Very minor. Telemetry quality is very good.
A range safety chart shows an initial flight azimuth of 196.067 degrees true. Looks like we got a good one here.
Henry Van Goey, manager of the unmanned launch operations at Kennedy Space Center, Western Test Range.
Of all of man's enterprises, exploration of the unknown has always yielded him his greatest return. And so it is with the peaceful exploration of space. The film you have just seen documents the efforts of the Kennedy Space Center's unmanned launch operations team here at the Western Test Range. As a team, we are all proud of our role in the National Space Program, which has contributed so much to education, technology, medical knowledge, communications, and to our posture as a world leader. But most of all, to the better understanding and protection of our environment. It is to this end that we here at the Western Test Range have dedicated our efforts. We have learned to build the tools of the space age. Now we must labor to improve them and to use them well for future generations.
Okay, Director Center, I've got some early orbital parameters here.
All right, what have you got?
These are only early reports, so they're really only approximations at this stage. We've got apogee at 1439 kilometers, perigee at 1356 kilometers, our spin rate's at 3.84 RPMs, inclination is at 88.153 degrees.